tomorrow will be better. Today again, I'll take you to physics, more specifically to thermodynamics. In this question, which is a past GC ordinary level question precisely last year, we are told that an electric kettle which is rated 900 watt was used to heat water of mass 2 kilograms and of initial temperature 30 degrees Celsius for 5 minutes. All right, and now we have the specific heat capacity of water, and be careful, it's being given in joule per kilogram per degree Celsius, not in Kelvin. And in this question they want us to find number one, the amount of energy delivered by this kettle within this time, and number two, the second temperature of the water, or let's call it the final temperature of the water. All right, so follow me, let's solve this. Solution. Usually before I attempt such questions, I always look at the quantities and their SI units, alright? In order not to fall into the trap of misusing or using the wrong unit, it's always preferable to make sure that all the quantities are expressed in their SI units. Let me begin from here. The unit of power is a watt. That of mass is a kilogram. Now that of temperature is a Kelvin. Alright, so I would have just converted this 30 degrees Celsius to Kelvin, but for the fact that looking at the unit in which the specific heat capacity has been expressed, I can see here that the temperature here is in degrees Celsius, alright? So there's really no need converting this to Kelvin. But otherwise, if this was given in Kelvin, then there will be a need to convert this. On the other hand, look at time. The SI unit for time is a second, correct? Alright, so I'm going to just convert this to second right away. Again, why this strategy? Just to avoid mistakes later on, right? So 5 minutes to seconds gives us 5 times 60, which is nothing else but 300 seconds, alright? I think now we're good to go. So solution number one, find the amount of heat energy which is delivered within this time. We know that there's a formula that says power is equal to the work done per unit time. And from there we can express that power, which is equal to energy, I'm going to explain this shortly, will be given by power times time. Where do we come from with the idea that power is the same, or rather, work is the same as energy? Remember our traditional definition for energy, which is the ability to do work. From this definition, we can deduce that work done is an effective measure of how much energy has been either gained or dissipated, okay? No doubt the two quantities have the same unit, which is the joule. For this reason, we can confidently interchangeably use them, one for the other, of course, depending on the context. So in this context here, we can replace our work done by energy without any problem, all right? So let us find energy, which is therefore going to be the power 900 times the time taken, which is 300 seconds. If you correctly do this, you're going to obtain 270,000 joules of energy. So within 5 minutes, this is how much heat energy was given or was supplied to the water by the kettle. Now, in the B part of the question, we are asked to find the final temperature of this water after this time. Now we know the formula which says the heat energy gained or supply is given by the product of mass, specific heat capacity, and then the change in temperature. And in this formula, our term of interest is the change in temperature, which again can be further broken down, but I'm going to show you later on. So from here, let's make this the subject of the formula, which will imply that this will be equal to pure divided by the mass times the specific heat capacity. So straight away, I'm just going to apply this. We already have this, which is 270,000, and then the mass 2 kilograms times specific heat capacity 4,200. If you correctly punch this on your calculator, this is going to give you 32.14 degrees Celsius. Many candidates just end here and think, oh, I've done it. But this is not a question you would ask. The second part says find the final temperature of the water, all right, after the 5 minutes. This is just a temperature change. So we would say, but temperature change actually is given by the final temperature minus the initial temperature. All right. Now that we have the initial temperature and the change in temperature, we can make the final temperature the subject of this formula. How? We will say this means that the final temperature is going to be the change in temperature plus the initial temperature. All right. So this will be nothing but 32 degrees plus initial temperature, correct, which was 30 degrees. And if you correctly punch this, once more, we're going to have 62.14 degrees. And this is the final temperature of our water after 5 minutes, because tomorrow will certainly be better. Thank you.